Okay, so hey guys, so as to not let you all feel left out in the super fun world of watching videos, I thought I would make a quick video with some advice about number 7 on the exam, which is number 43 from the textbook. So hopefully this advice will turn what is a pretty daunting problem into one that's a bit more manageable. So, okay, so of course this is the problem. It's very long and there's a lot of stuff, but the actual question part of the question is just asking you to confirm that this formula for the limiting probabilities works for n equals 3. So in other words, just 3 states. So first of all, I'm going to show you several let's make our lives easier kind of shortcuts, I think. So first off, I'm going to call the states, just so that I don't have to stick with that awful numbering. I'm going to call them A, B, and C, because we only have 3. So great. I'm sorry. Those are the what are the book calling it? Elements. I guess that's what they're calling them, right? So we only have 3 elements. So sorry, those aren't the states. Those are the elements, the things you can arrange. So then, of course, the states, as the book says, are all the permutations or arrangements of these, which you guys know what those are. I know you can all do this, but I'm going to just list them. Not that this is essential, but just for organization. It's good I think in general, it's good to list things in what I think the fancy word is lexicographical order, which is to say, of course, in this case, alphabetical order, right? So I think, not that you have to, but so that we're all on the same page, I might organize my 6 states this way, starting with the first one and then going to the last one, just because it's alphabetical. Okay, so of course the question, part A says, confirm that this is and of course we know that associated with A, B, and C, we have probabilities, which I'm going to denote PA, PB, and PC, right? Naturally, those are the probabilities that you pick A, B, or C as the next item chosen, or whatever they're saying here. Okay, so part A, of course, asks you to argue that when you do this choosing and move whatever you choose to the front, that's a Markov chain. I'm sure you can all agree and show, or at least discuss, why that is true. So let's get to the main question, B, which is to confirm that you have a certain formula for the limiting probability pi. Okay, so it's probably not an awful idea for you to just so you can kind of see the whole thing. I might encourage you, and it's sort of good for your health, I think anyway, to maybe go ahead and do the big matrix, just because it'll be kind of nice to see that actually the probabilities are not that scary, and in fact what you end up with when you list the states as you'll probably see, I'm sure you did this part already, that when you list them, so I don't have to keep doing it, of course you end up with a 6x6 matrix. But of course, most of the entries in here, I won't fill any of them in, but most of the entries in there are either 0, well, in fact, they're all 0 or one of these 3 guys. Right, because of course, well, anyway, okay, I'm sure you can all do that, and I'm sure you figured that out. And I think for each of them, you end up with for each column, for example, I think you end up with 3 non-zero entries, which are all the same, and 3 0 entries. Right, so I think you end up with, when you look at any one of the columns, you're going to be looking at 3 zeros and 3 non-zeros, which are all the same. The number that's in there is, I don't think I'm giving away any secrets here when I say, obviously, in order to move to the state that starts with A, you have to have just chosen A. So I don't think I'm giving away anything you don't already know, that this first column is some PAs and some zeros. And obviously, all the other columns are going to be are going to be rather similar. So here's my first, let's make our lives easier. I might say, if you don't want to write the whole matrix, at least just do the first 2 columns. Because of course that's going to fully talk about A, and the role that A, the sort of, what's the right word? It lets you, this will let us tell the whole story for A. And if we can confirm the thing we're supposed to show for A, then the same argument's going to hold when you had B or C as the lead. So number one thing to do to make your life easier, I mean, you could leave it, right? Maybe, in fact, you should leave the whole 6x6 matrix. But I don't need to do this for all 6 cases. I really just need to sort of do one letter all the way through to the end, because there's nothing special about A. The same argument that worked for A will work when I do those two and those two. All right? So first things first, we're just going to just show the result for A in the first position. Right? Because the same logic will apply for the others. Okay, so we've eliminated some of this stuff. So, all right, so how are we going to do that? Well, the claim, of course, is that you have a formula for pi. So what is the claim? So let me just get a clean slide here. So, of course, the claim that you're trying to show is that the pi, which, of course, I might think of as having, obviously it has 6 components, is the long-run probability of being in each of the 6 states. You might think about it as this. And so on. Right? Maybe I should write those down. Okay, so those are our 6 characters. I'm having trouble with the alphabet. So those are the 6 that we need to show. So the claim is that if pi is denoted that way, then the claim is that any one of these, which I'm going to go as X, Y, Z, so that I can say it's any one of those arrangements of letters, right? The claim is that this is equal to PX times, now of course they use this, I don't care for their notation, so I sort of like mine a little bit better. PX, so the first, whatever the first letter is in the arrangement, that's P, that P goes first, then the second letter comes second, divided by 1 minus the first letter. Now I'm just going to stop here and say you probably could say an easy, quick thing as to why, while there is an awful lot of other stuff in that formula, maybe just write a quick sentence or statement about why everything else that's over there is either not really there, or what is there is actually just 1. So one thing to make our lives easier is that we just actually need to show that. All right, so maybe just give me a sentence about why that box over there is non-existent and or just 1. Okay. All right, so we're down to this, and again, since we're going to try to make our lives easier, we're just going to try to show that this is true when X is A. So we really just need to show, because again, same argument will apply for whatever you have in the front there. So I really just need to show that if X is A, that this actually works. Now, of course, I only have 2 combinations, so this might actually be not too bad. But all I really need to do then is show that those work. So, of course, if I fill in the details here, that would be to say that this is PA, that's PB, and that's 1 minus PA. And then similarly down here, I just replace B with C. Okay, so your entire work in this problem is to show these 2 facts. So we've at least gotten ourselves down to a manageable situation. Now we're not done, and this is not obvious, and all of those things, right? But, all right, so that's our goal. Show those 2. So how do we show those 2? Well, if we think about it, these are, of course, both statements about pi, now PA, PB, PC, those are numbers that we don't know what they are, but they're obviously given to us. So we know that stuff on the right. But we don't know who these pi's are. But the claim is that it's equal to this. So how are we going to show something is true about pi? Well, of course, pi is the long-run probability. So I'm pretty sure we would have said this in class, although I don't have notes, but I'm pretty sure we would have said, well, what property of pi is perhaps a little bit useful here is that since pi is the long-run probability, of course I would say to myself, well, if you start in, if your chain starts according to pi, in other words, if you already start in whatever your long-run equilibrium situation is, then of course it's going to be unchanged when you actually move to the next step. In other words, if you start in equilibrium, you just stay there. So I think a mathier way of saying that would be to say if you took pi and multiplied by p, you'd still just have pi. Again, I'm pretty sure we would have said that in class, but in case we didn't, that's just sort of almost like the definition of what it would mean to be at equilibrium. It would mean to say, oh, hey, you move one step forward. That's what p does. Oh, you transitioned from pi to, well, pi, because that's the limit. Right. Okay. So I think that is true, right? So pi has to satisfy that. So maybe this gives us some hope now of saying, So who are these characters? Of course, those characters are pi times the first column. I'm going to go back to my matrix, right? So of course, pi p, I won't write it in, well, I'll temporarily write it in, right? Pi p would say take pi and hit this column, and then it would say take pi and hit this column. And those two results would be what are located in the first two slots of pi, because they're supposed to be equal, right? So pi times p, which I could do by taking pi, all of pi, all 6 things in pi, and hitting this column, and that should be the number that ends up there. Then I take all 6 numbers in pi, hit this column, and that's the number that should end up here. Right? So, I don't know if I should leave that or not. I'll leave that, right? But so these two guys, of course, those are the first 2 entries. Those are this one and this one. So I think I just need to show, to get all of this happy, or in order to get sort of a formula for this, the main computation that I think I'm going to do is to say, oh, well, since pi p has to equal pi, I think if I do pi times, I don't know how to say this, first column, or I guess it's a dot product at that point. That should be pi, and then the first entry is pi ABC, right? That's the first entry in pi. So if I take all of pi and dot it with the first column, I should get that. And of course, obviously, the second column is also true. Oh, this is looking good. Because now at least I have formulas for the 2 objects that we're trying to prove here or show here, right? So I'm going to say, right, since we're trying, and obviously we have our goal in mind is to show that it's that. But I think if you do just, the first 2 rounds of matrix multiplication or dot producting or whatever you want to call that, you'll at least get a formula, right? You'll get stuff that I think you can write down for those. And since P itself, I don't think I'm giving you too many details here, these 2 columns are entirely consisting of PAs and zeros. So obviously when you do the matrix multiplication, you every term you see has a PA in it. So you're going to get some stuff. Here's where I'm going to start to be a little more vague, I think. You're going to get some stuff, and you're going to get some stuff when you do that. And probably some stuff with PAs in them, in fact. Okay? So, well, that's good. So this is looking pretty darn good so far. Okay, but the devil is a little bit in the what else is here. Now here I won't say anything about what is there, but some other stuff is there. Now how do you turn that stuff into the stuff you want, right? So we're really just down to those 2 pieces. Well, I'm going to remind you that you know some other things are true about pi. And in particular, when you multiply, well, okay, right, again, I don't think I'm saying too much here, right? The stuff that's in here also has pi's in it, right? So my squiggles over here, there's some of the choice pi's, pi 1, 2, 3, 4, 5, 6, some of those are there. So you end up with, of course, when you look at this whole mess, it's in particular in the squiggles, you end up with a collection of pi's, right? So I think here's where I'm mostly going to stop talking is I'm going to say you should be able to use just some algebra and some rewriting in order to figure out a way to turn these two lines into these two lines. In particular, obviously, it's really just the circled pieces that you need to deal with. And my advice for how to do that is that, yes, while in theory you have a hot mess of stuff here because you got lots of pi's, you have 6 pi's. So in theory, of course, if you did this all out, you'd have 6 equations and 6 unknowns, which I suppose in theory you could solve, but that's pretty awful to do. So first of all, we're not going to do we're not doing all 6 equations. I'm allegedly telling you that you only need to do these 2. Now these do have pi's in them, though. You have all six pi's appear somewhere over here, I believe. So I'll just remind you that you do know some stuff. Obviously, if you add up all the pi's, you obviously get 1. Certainly, if you add up all the p's, you also get 1. I'm trying to decide if that's enough of a hint. I mean, that's mostly all you need, I think, to go. I mean, I'll be honest. Okay, so use those facts. Use those to help you morph these guys, these 2 equations. Look for things to combine. I'll give you sort of big hint, is that you do want to use that. You definitely want to use that. The fact that when you add up all the pi's, you get 1. That's going to give you a very nice simple equation for PA, I believe. Which is not done yet, because we're actually looking for formulas for pi's, not PA or PB or PC. But I think if you get a nice fact about that, and just sort of write down all the pieces, and so advice number 1, obviously that. Advice number 2 is that you can cheat a little bit. You can cheat in the sense that you know what your goal is. So you kind of know what you're hoping your algebra work over here turns into. You're obviously hoping it turns into the star here. So I found myself, I'll be honest, it took me about 5 minutes to probably figure out the right way to put things together to lead to the kind of fruitful thing. One of them, though, comes immediately, I think. I think this one, maybe my last hint. This one comes almost right away. So that one comes pretty directly from just writing down some basic algebra stuff and doing a very basic observation. I think you end up pretty quickly with that from combining a couple of statements. The second one, you can either, again, try to engineer that in the same way that you maybe got the first one, or at the very least, if you sort of, I found it actually a little bit useful to work backwards and say, all right, I want this to be true. Because of course, I mean, maybe I shouldn't, whatever, at this point I'm obviously giving you lots of hints. This one looks almost the same as that one. In fact, the only thing you need to be able to change is that when this changes to that, that changes to that. So in some sense, you can maybe use the first fact in order to help you generate the second fact. And maybe it's helpful to even write down the second fact and then just sort of argue your way backwards to the first, or you know what I mean. You can kind of work from both ends is what I mean by the second comment here. Okay, so I think I'm going to leave you there and say that it's all just some algebra, which I know if you're kind of not seeing a trick, it's maybe, but I do think that there's enough, you have enough in front of you, and while there are 6 of these pies floating around, there is obviously there's a huge pattern and hopefully some other cute things that you're noticing. So I'll stop there and say good luck on nailing this. And again, don't go any further than just showing these 2, right? Because there's nothing else that you need to do besides that in order to show the whole result. So at least it cuts down, I think, a little bit on what you have to do. So good luck. Send me an email if you have any questions or are really stuck and in need of some other light advice. It's Thursday, of course, today, so hopefully you're almost done or working your way towards being done and can upload tomorrow. If you think you need the weekend to work on it, that's fine, but maybe just send me an email so that I know, and I'll probably, well, anyway, let me know if you need anything, and good luck.